Hello everyone, so from today we are going to start a new series for the Maths B chapter-wise solutions, and we'll continue this for pure maths IGCSE. We'll do the same for the P1, P2, P3, P4, M1, S1 for all the 6 units of A-level maths 2. So let's start. We are starting with vectors of maths B. Now in vectors there are 1, 2, 3, 4, 5, 6 subtopics that need to be memorized, not like memorized, that need to be known in order to solve all the types of vector questions that will come across in your Maths B IGCSEs for both paper 1 and paper 2. Since this is for a chapter wise solution video, so I'm not only focusing on just paper 1 or paper 2. This worksheet that I'm solving in today's class is a combination for from the question papers of from 2019 to 2020 22 October, I think. Sorry, June, right? 2022 June, and all the questions are actually taken from a combination of paper one, paper two, 1R, 2R, combination for all the papers. Okay, so let's start. Let's first see that the types of vector questions that might come across into your exam paper. There are 6 types, as I've stated. Sorry. The first one is, I actually don't have much space over here, so I'll just write the types of vectors over here. Okay. Now I'll obviously tell that what type of question each question is before I start explaining that. First one is a very simple addition vector. Then obviously subtraction vector. Then you have addition, subtraction, parallel vectors. Then on fourth you have equal vectors. On fifth you have column vectors. And finally on sixth you have vector geometry, where basically you have to use vector concepts, basically column vector concepts, into the any kind of regular geometrical objects they're going to ask in the question. Now from all these type of addition, subtraction, equal and column, these are the most type of questions that come across in your paper 1, and vector geometry is usually part of paper 2. Sometimes they would ask vector geometry also in paper 1, maybe for like 4 to 3 marks, but usually vector geometry, they try to ask this kind of questions in paper 1 with a very big maths. Maybe that will have like 15 to 12 marks. And in vector geometry, you will come across those constant known as lambda and mu. Usually, in sometimes parallel vector, you also come across those constants like lambda and mu, but usually they are asked more frequently in the geometry vector. So I'll just write it like over here, lambda and mu. Okay. So let's start with the vector addition. Obviously, we're going to start from serially: addition, subtraction, parallel, equal, column, and then finally to geometry. Geometry vector is basically a combination for all the 5 types of vector in one diagram, right? So that's why that is the last topic for vector. Okay, so let's start. This one is a combination for addition and subtraction. Now, addition and subtraction is a very small topic. So we cannot just, like, as these are taken directly from question paper. So I could not find any one question that was like just only focusing on addition vector or subtraction vector. Okay, so we'll just use this as a combination for vector. It says that vector a, x and b are such that 2x plus 5a plus 3b, and they have given you the vector's value for a and given you the value of vector b. We need to find the value of that vector x. Okay, you just have to input the first values of each vector into the equation and then make x the subject of this. So which is like 2x plus 5, a is 9 minus 2 is equals to 3, b is 5, 4. So finally now you have 2x, 3 into 5 is 15 and 3 into 4 is 12, right? So you get 15 and 12. If you multiply this 5 and 9, like this vector over here, 5a, you get 45 and 10 at the base, and you just take that 5a, positive 5a to the left hand side, so obviously it becomes negative 5a. So it's going to be negative 45 minus 10, 2a, 2x. You can now say that you just have to subtract these two vectors from each other. 45, like 15 minus 45, you get minus 30. And for the base part, you have 12 minus minus 10. 12 minus minus 10, so you get 22. Further, you have to divide it with 2. Now, in a problem with vectors is that you cannot actually divide in vector. So what you will actually write is that divided by 2 actually indicates half multiplied to that, whatever you have, right? So you have this x, and you can write it like this. I'll just write the first format. 30, 22 divided by 2. Now I cannot solve this in this format because it is the vector is divided by 2, which is not into part of our syllabus. So what I'll do is that it obviously indicates you have this 1 and 1 in the front and 2 in the division, 2 in the denominator. So you can finally write it like this: half multiplied to that vector over here, 30, 22. So half multiplied with 30, you get minus 15 and 11, right? So finally minus 15 and 11. So these are the vector values for the vector x. This was most of the addition subtraction parts. In vectors, you can obviously change the direction of the vector, and then the normal basic algebra rules will be applied over here also. If the value of that vector is positive on the right hand side, when you shift that to the left hand side, it becomes negative, right? Basic algebra rules, nothing that much fancy for vector. So I think vector addition subtraction was clear to everyone. We'll be moving on to the next part, which is I think parallel vector, right? So we are done with vector addition and subtraction. Also, this entire PDF will be added into our page. So if you want to find out this PDF or download this PDF, please follow our Facebook page at Edexcel Easy to get this PDF, solved PDF of these chapter-wise worksheets. Okay, so we are done with addition, subtraction. Let's move on to parallel vectors. Now, while compiling this question paper, I forgot to compile it serially. So parallel vector and equal vector are compiled at the very last of this page. So we'll just move down. Right. This one over here is about parallel vectors, and this one, sorry, the previous one was about equal vectors. This is for parallel vectors. So let's start with parallel vector. Okay, now in parallel vector, they have stated that A, B and C, given that A plus KB is parallel to C, and find the value of K. Always remember that whenever you have two vectors parallel to each other, you cannot just write it like this, that you have this one statement, A plus KB parallel to C, right? That's what it indicates, A plus KB parallel to C. Problem is you cannot just input this into an equation and write equals to in between that. Like A plus KB equals to C. That's not possible, because whenever you're considering that two sides of an equation are parallel to each other, that indicates they have a certain constant in between them. Now obviously another thing that over here K is already acting as a constant, but this was a constant already provided by the question, right? In order to make it an equation, you have to introduce another constant. So whatever the case is, for example, maybe in your question they can also give you like informations like this: A plus B parallel to C. Then the equation for this relationship would be like A plus KB, like A plus B equals to MC. The M over here is a constant. Now in this case also, it doesn't matter if you have the K in front of B or not. You can. This was in a relationship format where the relationship between A, K, B, C were all related. So this is a relation. For equation, it will be A plus KB is equals to MC, where M is a constant that needs to be found out, and using that value of M, you can find the value of K. Over here, the question is actually interested to find out the value for K. So that M over here that we inputted into our equation, in order to make that parallel relationship into an equation, you can just find the value of M, or you cannot find the value of M. That's totally fine. So we'll just start resolving this equation from now on. Value for A was 5, 2. So you get 5, 2 plus K. B was 6 minus 1 is equal to C is 3, 1. So you have 5, 2 plus 6K minus K is equals to 3 over 1. And finally, you can write what this actually vector indicates is that all the vectors in the first column are equal and all the vectors in the second column are equal, right? Okay, another thing that I should have written over here is m multiplied to this. So the next line it would look like 3m with m over here in the bottom column on the right hand side, right? So what again this indicates is this. I'll just highlight the part. These first columns are all equal and the second the second columns are all equal, right? So we can just compare the first column and second column separately in two different equations. So it will look like that comparing first column, that is 5 plus 6k equals to 3m, and sorry, and second column would be 2 minus k is equals to m. So since you do not need the value for m, right, you're only focusing to find out the value for k over here. So I'll consider this as equation 2 and this as equation 1. I'll just rearrange the equation 2 and make it look like this. M is equals to 2 minus k, where it looks like that m is the subject of your equation and the value for m is 2 minus k. So you can just substitute that second equation into the first equation for that position of m. So it will look like substituting equation 2 into 1, and then it looks like 5 plus 6k is equals to 3, where m is 2 minus k. Eventually you get 5 plus 6k and you have 6 minus 3k. So you just take all the k to the left hand side and take all the alphabets to the, so all the numbers to the right hand side. So you get 6k plus 3k is equals to 6 minus 5. So now you have 9k equals to 1. Finally, the value of k turns out to be 1 over 9. Right, so this is how you're supposed to calculate or you're supposed to solve parallel vector maths, right? Whenever you're provided with an equation that two vectors are parallel, you always have to consider the fact an alphabet, a constant term should be taken into that relationship in order to turn that relationship into a vector. Over here, the question was telling you that a plus kb is parallel to c, right? They already had a constant over here k, but that is not enough. If you have to convert this relationship into an equation, you certainly have to take a constant over here to that part of c. So it becomes a plus kb equals to mc, right? The m over here makes it the left hand side equal to the right hand side. And then again, you just solve the equation like normal basic vectors part and compare the first column with the second column. Like separately compare the first column and the second column, and eventually you end up with two different equations. You do substitution method for this part and finally find out your unknown alphabet that you're trying to find out. Yeah, that's it then for parallel vector. We'll be moving on to equal vectors. For parallel vector, it was tricky part because we have to take that another concept as a part of your equation, right? But for equal vectors, they do not have that much problems or involved with it. So we'll just write this is equal vector. Okay, so first part over here, they have already provided you with vectors for P and Q and R, but for P you have this X over here as an unknown value, and for R you have this Y over here as an unknown value, right? Okay, so now it says that given that P plus Q is equals to 2R, find the values of X and Y. This statement over here, the equation that they have provided has an equal in this case, right? That's why they're considering this as a type of equal vector, because p plus q, summation of the two vectors, is equal to the twice of the another vector. So I'll just input the values of the each vectors over here and then again do the comparison. Like first column will be compared together and second column again will be compared together. So you get p plus q equals to 2r, where p is 4, 3 and q is x5, where r is again minus 2y. Simplified, for example, 4 plus x will just be 4 plus x, 5 plus 3 is 8, and equals to minus 4, 2y. Again, same thing, this first column is equal to each other, and this second column is equal to each other. So I'll just write comparing first column, which is 4 plus x equals to minus 4, and second column is 8 equals to 2y, which is basically y is equals to 8 over 2 and 4. So you get the value of y as 4, and over here you get x equals to minus 4, you have minus 16. So x equals to minus 16. So that this is how you're supposed to solve equal vectors. It's quite very easy, right? You just input the values of your corresponding vectors into the equation and then you compare the two columns over here, right? I'll just write it down over here. This is first column and this is second column. Usually they're not columns, they are rows over here. Sorry, I made a mistake because columns are the vertical ones, right? So, or second row. Then that's it for equal vectors. So we're done with equal vectors, we're done with parallel vectors, addition, subtraction. There's one more thing about modulus, right? Modulus is basically the magnitude of your vector quantities. Now, where do you actually see vector quantities? We see vector quantities in physics, right? Where we have scalar quantities and vector quantities. So these are also actually the sums of those vector quantities, but in a very simplified format. So that's why they kind of looks like that they are part of maths, but actually they are part of physics. Now in this case over here, for these vectors, obviously as we know vectors have both magnitude and directions, right? That's why directions was a very big matter. If the maybe vector for vector A is positive 2, in the opposite direction it will be minus 2, right? Minus 2 indicates the direction has reversed in this case. And similarly, if you're just focusing on that magnitude of vector, that's what we call the calculations for modulus. And modulus can never be negative. Now, modulus actually comes in a form of absolute value where the final answer will always be positive. Okay. So we'll start with modulus. That's it for equal vectors, right? So we have completed equal vectors, parallel vectors, and we will be moving on to the modulus calculation. They are again at the top of this PDF, quite disorganized, really sorry. We're also done with addition and subtractions, right? So this is for this is column vector, this is for modulus, right? So in modulus what we're supposed to do is that wait, maybe in the previous part also we calculated, yeah, over here this is also the modulus. How can I understand from a basic vector, or how can I understand that if they're asking for modulus or not? By looking at these absolute value brackets. These vertical lines before and after BC indicates that they are talking about the modulus of BC. They want you to find out the modulus of the vector BC. Now, before we move on to the modulus vector, let's just first understand column vector. Column vector actually comes in a pair with modulus, so it's not nothing fancy over here. So let's start column vector and modulus together. Now, over here for column vector, I would always suggest draw the triangle or follow the triangle rule. So I'll just use a different ink for that rough work that I'm going to do. This is for triangle method. So over here you have the points O, A, B and C are such that OA, this is 2, 4, OB and AC is provided. You have to find out the value of BC, like modulus of BC. If we have to find out the modulus of a certain vector, we first have to have that vector of that part, right? Like I have to have a certain value of BC, like in this format, maybe bottom and top, right? We do not have any value of the vector BC. So let's first find out the vector BC. Now over here, what OA and OB indicates? OA and OB indicates that whenever you're working with vector quantities always start with an origin, right? As I've already stated that these are taken from physics. I hope everyone can remember that displacement is the first vector quantity that we see in physics, right? That displacement is always considered a distance that is always taken from the origin. So in this part also, if you have to take with like work with vector A's angle will always be vector A's angle will always be considered from point O or point origin. O always represents the origin over here. So we'll just draw a triangle. OA, OB and AC is provided, right? So I'll just draw a very rough triangle. This is point O. Just keep it over here. This is point O and this is point A and B. This is O, A and B. And if you connect the AB together, like you obviously get the vector AB. Now again, the arrows over here are a very big fact. The arrow was from OA from this direction, right? Which means the vector was actually moving from O to A. So in that case, the directions should be over like this. OA, OB, and AB like this. And again over here you have this another vector AC, but we'll deal with that later. Okay, they have provided you with AC and I just maybe I can deal with that now. AC will basically be the distance of C from A, right? So maybe like over here AC. So this is point C again, and again AC indicates that the vector is now moving from A to C. So this is how the direction would be. You are entirely focused about finding out BC in this case. So BC should be in a different color. So like this. This is BC, the deep purple line. That's what you are trying to find out in this vector. But again, the direction should be BC. Now over here, you have the value for AC, right? In order to find out BC, you still do not have this part. So what you're supposed to do is that you can just separately draw the two triangles. You first focus on to find the value for AB, and then using that ABC, you focus on finding the value of BC. So we'll just move on to the main diagram. This is how the rough idea should be plotted into your mind, that what is the final quantity that you're trying to find out and how the other pieces of information should be connected to find that new final information. At first, you are trying to find out AB because that is required for the calculations of BC. So we'll start with, I'll draw a very rough triangle over here. OAB. Right. Another very important rule about triangle rule is that the vectors that are moving in the same direction are written as a summation in one side, and the vectors that are moving in the opposite direction are written on the other side of the equation again as a summation. Now in this case, your OAAB is traveling in the same direction. How can you understand that if they are traveling in the same direction? If you connect this point like with your pen, OAAB, right? You do not need to pick up your pen and find and move to the next angle. OA, AB, right? These two lines are connected to each other and they're all traveling in the same direction. So you can just find it like this, OA, AB. But for OB, you have to pick up your pen and then again move on to point O and then start moving in the direction of OB, right? OA, AB, but for OB you have to again move your pen or pick up your pen from the paper surface and move to that O point. So that's why you can understand that if two lines are moving in the same direction, you do this calculation or you do this method, that if you do not need to pick up your pen for two lines, that means these two lines are moving in the same direction. And if you have to pick up your pen and start to the move it to the origin and start from the origin, then that line is moving in the opposite direction. So OA and AB are in the same direction, whereas OB is in different direction. So the equation should be written like this: OA plus AB is equals to OB. Another very important thing over here is that these are vectors, right? For column vectors, you just always have to write that arrow in front of those OA, AB, right? So OA, AB, and OB, because these arrows indicates that in which direction these vectors are moving. So over here, now you're trying to find out the value for AB. From this point onwards, you can just behave like these are like equal vectors. This one, AB, we are trying to find this out. So it will be AB. If you just change this to the right hand side, it will obviously be negative in the right hand side, right? So it's going to be OB minus OA. So finally you get OB was 5 minus 3, OA is minus 2, 4. So you get, now again do the simple calculation that 5 minus minus 2 is 7, right? Positive 7, and for minus 3 minus 4 they are going to get negative 7. So this is the final vector for AB. Now using this AB you can find out that BC vector, right? Again I'll draw a very simple triangle over here. This is A, B, and C. Now you have AB, AC, and you're trying to find out BC. Over here, you can clearly understand that your arrow or vector is starting from point A, moving to point B, and from B to C. That means AB, BC are in the same direction, whereas AC is in the opposite direction. So we can just write an equation for this as AB plus BC is equals to AC, which is then going to be BC AC minus AB, because you know basic algebra formats, AB was positive at the left hand side, so you change that position and it becomes negative on the right hand side. AC vector was minus 1 as you can see from here, so it will be minus 1 minus AB was 7 minus 7 that you calculated in the previous part. So 7 minus 7. So you get minus 1 minus 7 is minus 8. And this one actually becomes plus 7. So you have 6 over here, right? So this is the final vector of BC, but this is still not the modulus, right? This is how you write the vector BC without any modulus signs or absolute value signs. For modulus, the working should be like this. The modulus actually has a formula for it. For example, whatever the vector is, maybe like the vector is m, okay, and it has x at the top, y at the bottom, and you have to find out the modulus. This was the vector. The modulus would be absolute value of this vector, which is x square plus y square root over. Always remember that modulus is always going to be positive, because modulus is the magnitude. Magnitude is a part of the scalar quantities, and scalar quantities are never assigned with negative signs, right? Negative signs are only assigned with quantities that are vector. They have to those vectors those have directions involved, right? Since this is a modulus, magnitude, these are quantity properties of scalar quantities where only plus signs are considered as the only option. So we're not going to assign any negative sign for this kind of cases. Even though your final answer is negative, you'll always choose your answer to be the positive one. How can your answer be negative over here? For example, if the value for this x square plus y square turns out to be 4, in that case, root over of 4 would leave to you as plus minus 2. We're obviously not going to consider the negative value of 2 because that's negative value. And this is for modulus, for scalar quantity. So we're going to end up with the positive 2, or we are just going to accept the positive 2 value over here. Okay, so I'll just write it down over here, always positive. Okay. So now in this case, if you have to move on to the modulus calculation, right, that is basically for BC, absolute value. Obviously always have to input these vertical brackets before and after the vector in order to show that you are using the absolute value. Absolute value is actually responsible for getting the positive part, because absolute value works as a filter. Even though your final answer turns out to be negative, you are going to still choose the positive value. That's because in absolute value, whenever you're working with absolute value, the final answer will always be positive, right? So you get minus 8 whole square plus 6 whole square root over. So you get 10, positive 10. So we're obviously going to just accept positive 10 over here. Right, this is the final answer for column vector and also for modulus. This is how you're going to solve column vector and modulus maths. Now for column vector, I always try to recommend that you draw a particular triangle or shape connecting all the information that was given to your question, like A, B, C, O. And then from those parts, try to find out that if you are trying to find out the final vector as BC, this BC is connected to this triangle ABC, and for ABC you have also another unknown, that is AB, which is again connected to this triangle OAB. So you have to first find out this AB, and using that you have to find out that BC. Right, so this is how you're supposed to interpret the equations for column vectors and use all the information provided in your question to find the final unknown vector that you are asked to calculate into the question. Okay, then this is it for column vectors and modulus as a combination. So we are done with column vectors and modulus also, right? I think we have another question with column vectors. This is also from column vector, and yeah, from then on we have vector geometry. For vector geometry, as I've already stated, that they do not have anything new over there. It's just a combination for all these type of maths into one maths, right? It's like a combination of all the types that you have seen so far for vectors. Okay, so over here you get the coordinates of point A is 7, 2. Another thing for coordinates, as they're talking about, coordinates are usually a part on a graph. And graph, how do you actually plot a coordinate? You always plot a coordinate with respect to the origin, right? So over here, point A also indicates that this in a vector format would be written as OA, right? From O to A. So point A has coordinates 7, 2, point B has coordinates 5, y, and they have already provided you the modulus of the vector AB as 13. So you have to find out the value of y. Okay, so let's start. Again, I'll do the same format. I'll just first draw this, write these coordinates in the form of column vector. Column vector is basically writing the vectors vertically in top and bottom. So you have 7 and 2. 7 always goes to the top, like the front number always goes to the top, and the back number always goes to the bottom. So you have OA, that's going to be 7, 2, and OB, that's going to be minus 5y. So these are the column vectors. So I'll first draw a triangle to find out the expression for AB vector. From this point onwards, it will be like a repeated part that to identify that which lines are in the same direction. Your vector was traveling from OA, from OB. So these are OA, OB, and AB is in this format. So AB is in this format, which clearly indicates OA, is in the same direction, whereas OB is in the different direction, right? So you have OA plus AB is equals to OB, which means you can just make AB the subject, OB minus OA. Obviously, the arrows on top of each vector is very important in indicating the directions of each vector. So, AB is minus 5y minus 7, 2. So you get minus 5 minus 7 is minus 12 and y minus 2. Right, this is an expression for AB. Now I already know how to calculate the modulus, right? Modulus of AB is going to be, I already know the final value, which was 13 over here. They've already provided. I'll just use it and solve it like a linear equation from now onwards. So that's like 13. Another thing, the calculation for modulus always is in this format, right? I'll first write it like this, that minus 12 whole square plus y minus 2 whole square, everything under a root. And if you're able to solve this, the final answer would be 13. So now if you just take this root to the right hand side, it will be square 13 on the right hand side, right? So you get 144 plus y square minus 2y, it's not 2y, minus 4y plus 4 equals to 13 square. Over here, you have to break this down using the formula of a square plus 2ab. I'll just do this as a rough work over here. Y minus 2 whole square, which is y whole square minus 2y2 and plus 2 whole square, which is basically y square minus 4y plus 4. Now in this case, 13 square is 169. So you have y square minus 4y plus 4 plus 144, 169 equals to 0. We can clearly see that this is going to create a quadratic equation from now, right? 4 plus 144, 169, which is minus 21. So you get y square minus 4y minus 21 equals to 0. So eventually, from here onwards, you can use a calculator. If you have this calculator, then you can just press mode setup. You can press this, sorry. Yeah, from mode setup, you can just press this button over here and it will move on to this page where you have to choose the second option, which is for polynomial, and then again select the second degree, because this is a quadratic equation, right? So for quadratic equation, the degree is second degree. So you press 2 over here. This is how the equation will look like now, how your screen would look like now. You have the value for a as 1, b as minus 4, c as minus 21. So you press 1 and press equals. The block will shift to the right position for b, which is minus 4, and then press equals. Then the block again move on to the last part, which is minus 21. Press equal for the final part, and you get your value for x1 as 7 and x2 as minus 3. I hope everyone can understand how to do middle terms by this time, right? So it was minus 7 and 3, x1 minus 7, x2 was 3. I'll just have to move this to the right because I do not have much space. This one was for rough work. Okay, so now I'll just split that 4y over here in terms of 4y square. Negative 7 would be positive 7y and negative 3y minus 21 equals to 0. Yes, the splitting is correct because plus 7 minus 4 minus 3 then ends up to be, maybe I made a mistake. It should be like opposite of the sign over here. Right, okay, so you might have got positive 7 and negative 3. So in that case, over here it's going to be negative 7 and positive 3. So finally you take y as a common factor, so you get y minus 7 plus 3 as a common factor, and again you get y minus 7 equals to 0, which is y plus 3 and y minus 7 equals to 0. Finally, you can just see that the values for y is going to be either positive 7 or the value would be minus 3. Now, if I go back to your question, they were also asking about the possible values, right? So that means the value of y could be there could be multiple values of y. So we got 2 values of y, which is completely fine, nothing to get worried about. And this was a rough work, so I'll just draw it in a very, wait. Okay, so this is how you're supposed to solve the column vectors and find out the modulus. And using the modulus, you can find out anything unknown that was originally present into your vector. Yeah, this is it then. From now onwards, we'll be moving on to like column vectors. These are mostly paper 2 maths I've already stated. Yeah, so that's it. Let's start.